Hey everyone, so Ms. Silenok here. Welcome to your first official lesson in probability. So we are now officially done with our statistics section, and we're now going to be moving into probability. So first thing we have at the top of our notes is just probability and giving it some kind of definition. So I think a lot of you guys are familiar with that word probability, and hopefully what comes to mind when you think of that is how likely something is to happen, right? It's like, what's the probability of flipping a coin and it landing on heads? Right? Maybe some of you guys kind of think of that. We're going to actually get into some of those specific examples in our notes here. So for our definition, we're going to write for probability, how likely something is to happen. Now, the majority of our lesson today, we're going to be talking about something called sample space. So when we get to the practice problems down here, a lot of them are going to be asking you about sample space. So it's important that we actually define what sample space is. So sample space simply is just all possible outcomes of something occurring. So I'm going to write all possible outcomes. So again, back to that flipping a coin. If I said, okay, what's the sample space of flipping a coin? Well, what are the possible outcomes of flipping a coin? Well, miss, you can either get a heads or you can get a tails, right? So a common way we're going to be writing sample space, I want you guys to do the best you can to write these little like squiggly brackets like that. And you would just write, for our example on flipping a coin, you can get a head or a tail. That's it, okay? If I told you guys, hey, what's the sample space of rolling a six-sided die? You're thinking, okay, miss, well, when I roll a die, I can either land on the number 1, 2, 3, 4, 5, or 6. So meaning my sample space for rolling a die would be 1, 2, 3, 4, 5, and 6. You write out each number separated by a comma, okay? The last piece to defining some terms here for our notes is the difference between uniform probability or not uniform probability. And a good way to think of it is for uniform, right? You guys wear school uniforms when you come to University High, right? That means everyone has to be in the same uniform. Everyone has to be wearing the equal amount of options that we have for clothing, right? So it's either the khaki pants, the red or black polo shirt, the fleece, whatever it might be. For probability, uniform probability means that each element in our sample space has an equal chance of being selected. So when you guys flip a coin, right, there's an equal chance of landing on a head as there is landing on a tail. For rolling a six-sided die, there's an equal chance of rolling a 1, 2, 3, 4, 5, or 6. That would be considered uniform probability. So uniform probability, our definition, we're going to say where each element in the sample space is equally likely. Okay, so then you can assume for not uniform probability, it'd be the opposite. It would be where each element in the sample space is not equally likely. So let's say, for example, like a weighted die, we're gonna bring that to the example over here in a bit. If you had a die where each number is not only listed once, so see how the 4 is listed once, the 5 is listed 2 times, and the 6 is listed 3 times, that means that I do not have an equal chance of landing on a 4, 5, or a 6, right? Most likely when I roll it, I'd get a 6 because that appears the most times, and then maybe a 5 because that appears the second most times, and then my least likely option would be a 4 because that only comes up once, right? That would be considered not uniform probability. Okay, so for our definition, where each element in the sample space is not equally likely. Okay, so now some practice examples we can get to. So again, we're going to say flipping a coin, it's going to say sample space and then whether it's uniform or not. So these couple ones we can buzz through because we've already talked about them. So flipping a coin, we know our sample space is either a head or a tail, and that would be considered uniform. You have an equal chance of flipping a head or a tail. Okay, rolling a six-sided dice. So again, our sample space, the number is 1, 2, 3, 4, 5, 6. That would also be considered uniform because I have an equal chance of rolling any one of those numbers. Okay, spinning a 4-color spinner. So our options are red, yellow, blue, green. So we're going to write out red, yellow, blue, green. Since those are broken up evenly by quarters, or I have an equal chance of landing on any 4 of those colors, that would be considered uniform. Now your weighted out, we already talked about how that's not uniform, right? Because the numbers appear more than once and not equally, so that's going to be not uniform. When you're listing the sample space, you do not need to repeat numbers, okay? So all we list out is 4, 5, and 6, okay? For the last 6 here, guys, so our sample space for our ice cream, so our options are chocolate, vanilla, and strawberry. So I'm going to write out chalk, I'm going to abbreviate vanilla, and then I'll abbreviate strawberry with straw, okay? And I have an equal chance of selecting each flavor. Sure, we consider that being uniform, okay? Determining the gender of a baby, so you can either have a boy, you can have a girl. Those are pretty equal options of which gender you might have, generally speaking, okay? So our sample space is going to be girl, comma, boy, and then that'd also be considered uniform, okay? Now picking from a bag of marbles. So on your sheet of paper, you have some R marbles and you have some B marbles. The R's are red and the B's are blue. Since there are more reds than blues, that would not be considered uniform. And again, my sample space, I would just list off as red and blue. You don't need to list them more than once, okay? Your spinner at the bottom here, okay, it looks like we have YRGB for yellow, red, blue, green. So YRGB, okay? Since these are not equal spaces on my spinner wheel, right, there's not an equal chance of each one being spun on, so this would not be considered uniform, okay? Our bag of marbles, okay, so we have 1 red, 1 green, 1 blue, so sample space, red, blue, green. And order doesn't matter, guys, you can list them whatever order you want, okay? And yes, that would be considered uniform because there's 1 of each. And go ahead and cross off the letter tiles. I hate that example. It's annoying how half of them are covered up, half of them aren't, so don't worry about that one, okay? If you guys flip over on the back now, okay, so in this unit, we're going to be referring a lot to a standard deck of cards. So in your notes here, I provide with you guys what each card would look like, okay? So if you're unfamiliar with the deck of cards, this will be a great reference for you, okay? You have 4 suits here. So the top one is a spade, the next one's a club, diamond, heart. If you aren't familiar with these suits, guys, I'd go ahead and just write down those names next to each. So we have spade, club, diamond, and hearts, because some of the problems are going to ask you about those suits there, okay? And then if you notice, the numbers will only go from 2 to 10, and then you have your ace, and then you have a jack, a queen, and a king, okay? And we have a total of 52 cards in a standard deck, okay? The last section here, guys, we're going to end with the tree diagram. We're going to skip the bottom table or chart section here. So tree diagram for flipping a coin twice. So now we're actually going to visually show how we're going to be forming our sample size based on a tree diagram. So flipping a coin twice. How I always want you guys to start your tree diagrams here is just by making a little dot off to the left-hand side, okay? If I were to flip a coin 1 time, my options is 1 branch, head, my other branch, tail. That would represent me flipping a coin 1 time. So I can either get a head or I can get a tail. Flipping a coin twice, though, I need to branch off those 2. So what I mean by that is, okay, let's say you flipped your coin the first time, you got a head. When you flip it a second time, what are your 2 options? Well, you're either going to get a head or you're going to get a tail, and that's correct, okay? Let's say you flipped a tail the first time, right? The second time you flip, you can again get a head or a tail. So that's going to be a tree diagram to show us all the possible outcomes for flipping a coin twice, meaning I can get a head or a head, so HH. I can get a head and a tail, HT. I can get a tail and a head, TH, and I can get a tail and a tail, TT. So that's going to be 4 possible outcomes. So my sample size is 4. Uniform. So do I have an equal chance of getting head, 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 tail, tail, head, tail, tail? Yes, I do, right? That would be considered uniform, okay? Your last one, randomly selecting 2 scoops of ice cream. So again, starting my sideways tree diagram here, you guys are always going to start just by making your little dot off to the left, okay? But for selecting your first scoop, we're going to use the same flavors on the front side of our notes. I can either have chocolate, I can have vanilla, or I can have strawberry. Ha ha ha, CVS. Yes, we made this joke in my other classes, the CVS, like the pharmacy here, okay? So this would be representing choosing 1 scoop. Now for your second scoop, you're going to branch off again. So let's say you chose chocolate as your first scoop. Your second scoop, you can either have chocolate, vanilla, or strawberry. Let's say you chose vanilla as your first scoop. Your second scoop can be chocolate, vanilla, strawberry. Let's say you chose strawberry as your first scoop. You could have for your second scoop chocolate, vanilla, strawberry. So now listing out my sample space by just going down each branch, I can have chocolate, 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 vanilla, chocolate, strawberry. So CC, CV, CS. I can have vanilla, chocolate, vanilla, 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 strawberry. So VC, VV, VS. Or I can have strawberry, chocolate, strawberry, vanilla, strawberry, strawberry. So SC, SV, SS. When you guys count all of those up, that should give you a sample size of 9. And yes, that would be considered uniform because I have an equal chance of selecting all those possible options of 2 scoops of ice cream. And we're going to stop here.